AI is a hot topic at the moment. We're getting asked in ER Studio land a lot from our customers about how we can help with AI. There's quite a few questions that we seem to get asked around this, so we'll put some of these on the screen. And Don has got some good answers to a lot of these. So I'm going to ask some questions, then Don's going to answer them. He's then going to take us through some pragmatic ways that we can really sort of go to town on answering these questions. So the sort of things that come up for us a lot. First one, how can I keep AI from hallucinating? So great, we point our AIs at all of our data in our organization, and we're getting sort of information back where the picture's got 7 fingers. Okay, so how can we sort of help with that? Don, so AI hallucinations, what do we know?
So hallucinations are based on, actually are sourced, we can trace those back to incongruities in the knowledge that the LLM is running on. We can trace them back to gaps and, just obfuscations. And so our method of, and we'll talk about this in the next, I think in the subsequent slide, but our method is for the core knowledge of how the business works, the business architecture. We don't train the LLM. We directly tell it what the knowledge is, and you'll see that in our model how that works. And so, we're talking about eliminating the sources of hallucinations that are focused on actually understanding the business architecture by directly telling the LLM what the business architecture is. So that's our method of dealing with that issue.
Great, and I guess that gets onto the next question. So we get asked a lot, can we use data models? How can we train the AI to prevent some of those hallucinations? We talk about guardrails that can sort of prevent the AI sort of coming up with the 7-fingered results. What's your thoughts?
Well, so the metadata, yes, you can train the LLM on your metadata that you have internally, but just recognize that your metadata has significant gaps. We see clients trying to train the LLM based on the catalogs, extract business information from the database catalogs, from the glossaries. The problem with that is that those data stores for metadata are really subject to essentially to the orientation of or the thought orientation of the people who wrote those definitions, right? The data catalogs are very engineering focused many times. The definitions are very engineering focused many times. They're not business aligned. The business glossaries themselves have a number of problems in them. Many times they have incongruities in the definitions. They have obfuscations. They have gaps, and they're not connecting one thing to another. One subject to another based on the way the business processes connect one function to another, right? So essentially, we recognize that there are huge gaps in information within an organization, and so we take this very direct approach in ensuring that the LLM has the necessary information it needs.
In terms of information that we have about the information of the organization, there's different sort of bodies of that information. So the next question, data models, everybody on this call hopefully is familiar with what is a data model. We're using ER Studio. Business glossaries, I think we're happy with that. So we've been talking a lot with ER Studio about, okay, you can create a flat list of business terms, and ideally you'd have those business terms arranged into models to show things like taxonomies. The data catalog is the sort of technical data dictionary of data assets, the schemas of those connected to the business glossary. Then this thing called a knowledge graph, and so a lot of our customers are starting to get worried. Okay, are these different things? What is a knowledge graph? We've heard about it as something that is generated by AI tools that can be run on our data. We've heard about it as things that allow us to define data within a graph-based database. So what is a knowledge graph, and then how does it sort of compare with the other things?
Yeah, so the primary difference between all of these things is the consumers, right? The consumers of the business glossary are business people. We create the glossary to align the entire organization on a common understanding of the business. The data models are there, and I'm actually talking about when I use the word data model, I'm going to present what some would refer to as a data model. I actually refer to it as a business architecture model or a knowledge model. But the data models are actually more focused on creation of a particular solution, a data organization that's conducive for the solution requirements, right? And then the knowledge graph is really information that is, business information that is consumable by the, and organized in a graph format for rapid searching by the LLM to supply it with the knowledge it needs, right? So it's really, those are really should be separated by function. They should not be separated by the definition of the business data that each uses. Unfortunately, they are created based on, by different constituencies and according to, the thinking of different groups of people. What we're going to show you today in the model is the common foundation that should drive all of those. We've written, essentially this is the same foundation that the data should be shaped around, in the metadata of business definition and relationship should flow into those solution data models. The business definition that we provide is actually high quality definition, should be flowing into the glossary, and ultimately we use this as a foundation for seeding the knowledge graph with the core knowledge of the business architecture.
So would you say in an ideal world, we've got all those different people operating properly, those different groups, would those pieces of information be the same, similar?
Yes, and as a matter of fact, if you think about it, the really cool thing about we have a unification across all of those, right? So now the business people from the glossary understand the business in the same way that the data solutions are created on. So we get a unification of data governance with our data architecture, and if we have the common foundation of knowledge in the knowledge graph, then we can start thinking about integrating enterprise data into generative AI function for business. So there's great power in actually unifying those functions, those uses of data around a common business architecture foundation or definition.
Nice. And then the last question, where do we get started?
Well, that's kind of what I'm going to show you. Accenture has a product line within its AUDM group of products that are business architecture models. They are every bit knowledge models that are capable of supporting both the LLM as well as, and the way I use them is I also use these same models for creation of solutions, whether they're relational solutions. I even do a demo with one of these models with our payer model, where I demonstrate how we shape dimensional solutions and star schema models out of the business model, so that we ensure that our star schema models are fully aligned with the business architecture. And so that's essentially the unification story here. This is the common business knowledge model, and we'll talk about this in another slide. But entity relationship modeling is really its origins, its foundations are actually in this capability of modeling knowledge about the business.
Nice.
So,
and the Accenture product that we're talking about, the core of this is the AUDM. What does AUDM stand for?
Accenture Unified Data Model.
Easy. Great.
Yep.
I just noticed in the chat, Tim was saying, if you've got any questions, there's a little question box there. We'll try and answer some questions along the way. We're going to save 10, 15 minutes to answer questions. Cool. Right.
Yep.
Let's move on to the next slide.
So as I implied in the previous discussion, we're not training the LLM in the sense of trying to train it based on a whole lot of different sources of data when it comes to the LLM's understanding of the business architecture. We are directly modeling that knowledge and then essentially importing that into the knowledge graphs from our models. And I'll put the plug-in for ER Studio here. You'll see some of this and why we use, and I'll speak to it again, but we find ER Studio and we find entity relationship modeling much more effective in terms of modeling knowledge than UML or knowledge graph modeling tools. The entity relationship tools are actually much further ahead in terms of their capability in doing the things that we're going to show you, and the constructs are exactly the same, which I'll speak to again. But what we're modeling here is really a linear story that allows us to identify the gaps in our knowledge, and it allows us to identify the incongruities in our thinking and the obfuscations, right? And that's really the story here. Just as a author would just as somebody writing a story or writing a book presents a series of ideas or concepts, essentially ideas that build on one another in order to form a body of knowledge that the author wants to impart to the reader. That's how we're developing the models. It's really important that we're able to visualize that, and in order to get that story correct and create that full body of knowledge. And that's what entity relationship modeling does better than any other tool, better than UML, and certainly better than the very primitive modeling capabilities of most of the graph tools out there today. So that's why we prefer that. We find entity relationship modeling very effective for this.
Good to hear.
Yeah. Next slide, please. So the constructs of knowledge that we're dealing with are exactly the same between entity relationship modeling, knowledge graph modeling, or even UML. The thing that's the subject or the object of the information is the node in the knowledge graph. The entity is the same construct in the entity relationship modeling. They have a name, they have a description. The node and the entity have characteristics. It's the label or the properties if people are thinking in terms of UML, because UML is often used for creating knowledge. But the labels are really the characteristics. In entity relationship modeling, of course, we have the attributes that are the characteristics of the thing we're modeling. The fact-to-fact or subject-to-subject association in how one thing is related to another is the edge in the knowledge graph. In entity relationship modeling, it's really the relationship. The edge has a name, which is a predicate of how the subject relates to an object. So it is a sentence structure. It is language based. And in entity relationship modeling, of course, we have the verb phrasing. Now, typically, the verb phrasing isn't done very well in most of the models I encounter, even most of the enterprise data models I encounter. You're going to see some good examples of what we think verb phrasing needs to be. because the verb phrasing is an explanation of the relationship that's formed between one entity and another, one function. And you're going to hear me talk about business functions, entities as functions, but one function and another, how those relationships are formed by business processes and according to functional support of a particular subject. All of that is intended to create a language, essentially form a model based on a language narrative of business function. And so those constructs are exactly the same between the knowledge graph, between UML, and between entity relationship modeling. Entity relationship modeling just happens to give us a much more robust tool set and a much greater capability in terms of formatting that, so we can actually see the story and visualize the story much better in order to work out the incongruities in our knowledge.
So three techniques, all to achieve the same aim. You could ideally use any of these to achieve the same goal, but you believe that ER modeling is the best?
I do. The primary difference between these is really the storage of the metadata, right? And I think largely you guys are probably headed toward, at some point in your future, headed toward a graph storage method, right? So it's really the storage. It's not the actual information that's provided by the models, or the information capability provided by the models.
And ER models have got a graphical element that is very business friendly and easy to understand.
Oh, extremely. Yeah, that's exactly why the utility of the utility of laying out that narrative so that you can see it. If you've ever used graph tools, you know what the limitations are. You get lost in the graph organization, and you don't see the story very well. And it's important to see the story. It's important to have that if you're going to actually model knowledge. So, yeah.
Okay.
Just very briefly, entity relationship modeling really has a rich heritage as a knowledge modeling tool. We don't recognize it today because largely a lot of modeling is done from an engineering standpoint. But E.F. Codd, originally the father of the relational database, and what we do entity relationship modeling, what we associate entity relationship modeling with today, in creating relational databases, is really his main goals. If you ever read his 5 goals for normalization, one of those was to make the data model, make the tables and the relationships to one another more intuitive and understandable by the business, so that the attributes are really formulating the characteristics of the function that the table was designed around. Now, he didn't go very far with that, but he wanted to make, essentially, if you look at the normalization rules, what they really do is that we purely define tables around business function and sub-function that you'll see in the model I show you. Peter Chen came along in the mid-70s, and his goal was really to bake into the model the semantics, really, of the business semantics, the language of a real world description of what the data represented. And then, of course, Clive Finkelstein with information engineering was a huge proponent of the predicate, the relationship verb phrasing that we use today, right? That we don't see used very much, but you're going to see some good examples of what that needs to be like in terms of use of language and the explanation of the relationship. So when I refer to function as I go through this model, what I'm talking about are human action patterns dictated or controlled by business processes. That forms a function, essentially, that is much like a function in a procedure stack. It does a discrete action. It does a specific thing according to a pattern. And that's what we're modeling, is we're modeling patterns of action. Those are the basis. Those patterns of action are the basis for half of the business terms that we use today. And the other half is measurement of those business functions, right? So all of the business terminology is actually based on what we model. And so essentially what we're doing is we're making that abstraction, the thing we call data that we refer to very abstractly, we're making it very real. The language elements that are the characteristic, that business processes generate, essentially those are done according to a set of characteristics that describe those functions that we're modeling. And so that's really the background. That's really the mindset that we go into modeling with when we're modeling knowledge and we're modeling data for the business architecture. Next slide, please. And so I'm going to very briefly speak to this. There's a series of articles that I've written out on LinkedIn. If you can stand my writing style, I think there's some good content, and it's a primer. It starts you out with the very basics of what ontology and taxonomy are. I find that there's many in the data and analytics space today that they use the words, but they don't understand what they really mean. And so a primer is necessary to kind of build the knowledge. Right now there's four articles out there. I have a fifth about to release, and there's a sixth one coming behind that. But it builds what you need to know essentially around what ontology and taxonomy are. They are central. Taxonomy and ontology are central to the modeling we do, the thought discipline and the use of language that we apply in these models as we create and we define what the business knowledge is. And so, I just encourage you to at least study it. If you don't even read my articles, go out and study it on your own. There's some information around ontology, misinformation around ontologies out there, but it is central to being able to do this kind of work correctly, and it's really a training of the mind in order to focus on the right things. So that's all I'll say. But essentially, I think that is important to anyone who's trying to master and create business knowledge for the LLM or model data according to the business architecture. So I think I have. Let's take a look at the model. If I can get the screen shared, Jamie, and I'll walk through this. I'm not going to be able to do this justice. Hopefully, you get a glimpse of what we're talking about in terms of the kind of modeling needed: entity relationship modeling, enterprise modeling, and I'll try and leave 15 minutes at the end. Jamie, please keep me, corral me if you need to. Yeah. So let's see, showing screen. I'm showing the wrong screen, sorry. Monitor one.
Data architect with a big, long model.
Oh, was that what you were seeing?
Yes. Was that what you were trying to do? We now see a beautiful countryside mountain scene.
Oh, okay. So are you seeing the model now?
Yep.
Okay, cool. So what you see here is a banner style model. We do this rather than a lot of different sub models. What this does is this allows us to lay out information according to a flow of, or lay out the knowledge according to a flow or of dependency of business function. So essentially on the end, and I'm going to zoom into so you'll see what we're talking about. But on the end here, essentially we have all of the actors. We have the product definition In this case, this is AUDM's insurance P&C insurance model. Okay, we have a number of other industries covered as well. These are great starting points if this, where we can essentially drop this in and then align it with your business architecture and your nomenclature. And we can do that for a number of industries. The product definition here in insurance, there is what's called the insurable subject. It's also referred to as the insurable object, the exposure, the coverable, the insurable. A definition. It's an ontology of many different classes of sources of risk exposure. Then essentially the sales domain of subjects, including the submissions and the submissions and quotes and underwriting activity, and then finally the agreements domain, including the policy term, reinsurance contracts, surety bonds, and then finally the fulfillment of those of the agreements of those contractual relationships in the loss domain, including the loss incident and claim and recovery and legal actions. So essentially, there is a flow of dependency, a left to right flow that we lay out in the model so that we can see what we're missing. And then we can fill in those gaps. That's an important aspect. The other important aspect is this phenomenal utility. If you're just doing these at a submodel level, you end up replicating entities many times, naming them slightly different, things like that. It's very difficult to put things together. We can pull down and create a perspective for a star schema model out of this model based on different subject areas, throw them into a perspective like I have here, and I can create subject areas. I can create specific illustrations, pulling from subcomponents of a particular subject area and putting together relationally with other subcomponents down on the other end. So I can put the policy together with the claim, let's say, and I can do so from a central model rather than trying to find it in different submodels. And so we model at this level, and then we create those submodels. So that's an important part of this.
So what we're looking at, and this is an Accenture product. This is a reference model. So you've got reference models for a number of industry sectors. So I'm an insurance company. I want to start off creating a knowledge model that can drive my LLM. So I can come to you guys. You've done the work. You've created a standardized view of different industries. Here we're looking at insurance. So what we see on the screen is an insurance company on a page, all the information associated with an insurance company, and you've broken it down into lots of submodels and organized view showing all the entities within that knowledge model, that business knowledge model.
Yes, and these are because we sell services with this. Our pricing of these is ridiculous. It's a ridiculous value. We don't charge very much compared to competitors for these kinds of models. What you get in this is very robust detail. You'll notice that. So besides the narrative, as we move across, and I'll show you a little bit about how that works in just a second. We also have a flow. So we have that flow across the model in terms of dependency. We have a flow within the subject area of the policy is a specific function. Its action is the policy establishes the contractual relationship between carrier and a policyholder, controlling the exchange of financial loss protection for premium paid by the policyholder. So that's essentially the action story of the policy function. We approach our definitions that way because each of these things do something within the business architecture. Further, there's a flow of knowledge within the model as well, in that we define each of the subfunctions. So we very much view that each of what we call entities or child entities is really a subfunction that functionally supports the parent function, in this case, the policy. And so if we look down at and we see this in the verb phrasing, we express this as part of the verb phrasing, giving the maximum amount of information to the human user as well as the machine user. And so in this case, the blanket policy coverage specifies and controls class of loss protection that is general to the policy general to all policy insured subjects of a policy. And the alternate relationship to the scheduled coverage, of course, is specific to the policy insured subject. And so I'll come back to this example because I'm going to talk about ontology and taxonomies in a moment. But that is, that's the mindset through which we create the business knowledge, and we are, essentially we align both data solutions as well as the LLM and the glossary with the business architecture, right? So let me pull up my notes here very quickly so I don't lose my place. So that gives you a little sense of the fact that we're also focusing on function. Besides the flow, we focus on the function. I mentioned earlier that we're in doing that, we're removing any of the obfuscations of the modeling abstraction. That's one of the problems, is modelers tend to think very squishy because modeling abstraction language is squishy, allows you to think in any way. We kind of trained the way we think on modeling function. That's very important. We focus very precisely on the nature of what data really is, what it describes, that it's a set of language elements and characteristics. We don't do any generalizations in the model. Oops, I even closed that. It even popped up. So we don't do any generalizations. So one of the things that's an issue that you will have difficulties with in using an enterprise data model is if it's overgeneralized the business, and all of the data about the taxonomy of the function is embedded in its metadata rather than the model itself. So, for instance, a party model where all of the taxonomy structure of individual parties, if your party model kind of does that, and it kind of generalizes them up to an abstraction called party and party role association, all of those things, that's not a business taxonomy. That's not business knowledge. That doesn't tell you how the functional structure of an agent or an agency or a policyholder. So that's where you're kind of missing the business knowledge in those areas, as well as probably how you're associating that. So these models are very much about functional taxonomy, and so essentially the generalization is kind of the overgeneralization, I should say, is the enemy of business knowledge. We do ontology generalizations, but they are specific to essentially explaining, commonality of structure in that. So I'll come back to that in just a moment. So let me kind of zero in on. I've got about 10 more minutes before so let me zero in on a couple of things as well here. So one of the other things that we find very useful, I will let me do this. So we looked at the policy and I explained that. So the way that the narrative works in a linear fashion then between subjects, and this can be at any level, either at the business function level or the sub-function level. But in the relationships, as part of the narrative flow, right, we carry these relationship predicates that are rather robust. So as well, and this is part of the overall general flow of the knowledge of the information that's baked into the model. So the policy term earns premium daily for protection defined by a policy, and that policy we've defined over on the other side, right? So these And you'll see that also in the metadata. We include some of the metadata of the entities in various places in the model. We define what the subject area is about. The policy term exchanges coverage protection defined by a policy for a promised length of commitment on the part of a carrier for the premium paid. Essentially, and we define this, and essentially all of this color means something. This particular kind of purple means that this is a transaction, right? And we define a policy term as a transaction because it exchanges premium daily, earned daily as part of earned premium for protection that's provided daily. And if you ever cut off a policy midterm and you get a refund back, that kind of proves it because they haven't earned the premium, they haven't provided you the protection as of the termination date, so you're getting a refund of your unearned premium. And so once again, our structure, everything in this is very narrative based. It's all language based. We understand the invisible patterns. The reason this is all important is because we can only recognize and understand visible patterns and visualize it based on the language narrative. And that's why modeling has always, entity relationship modeling has always been intended to be a narrative exercise. A couple of other interesting little features in here in the model. Let me go back to that we find extremely useful. And I'll show you a couple of things that we do, give you a little bit of the secret sauce. Entity relationship modeling, we find, is much better for this kind of work, for knowledge modeling, than UML. Although UML is used probably more extensively than entity relationship modeling. But UML is just not capable of doing some of the things that we need to do. And so, for instance, the expression of taxonomy hierarchy versus ontology generalization. So taxonomy is a differentiation or dividing in order to establish identity of a thing. And so a policy can be generalized as a personal policy or commercial policy. And then typically what happens is in these kinds of specializations, there is a structural component that goes along because function, as you differentiate it, becomes more refined and more specific. And so what we see is in the commercial policy, this allows us to express some interesting business rules, such as claims made and tailing date is applicable to all commercial policies, and they can overlap, so we create two different subtype clusters. The workers' comp policy can have additional structural components, the excluded workplaces, and potentially, depending on how you're dealing with them, you can have employee lease contracts that are documented under the policy structure, and whether or not those are included or excluded under the policy, right? So this ability to express taxonomy specialization is really important. One of the things that we do in this is we actually, and I'll show you this in a moment, but we actually classify, and it will be even if this was baked into some of into the tools, it might be a little easier, but it works really well with the way we're doing modeling as well. So we use attachments a good deal, but you'll notice a couple of things here. I'm going to show you, this is an example of an ontology grouping. And what we have here is we have an entity class type. Hopefully this is large enough that you can see it, but it's a taxonomy class. So everything that is truly a function is functionally defined. We can identify as a functional pattern. We give it a taxonomy class. Now, there are some very useful business ontologies, and they exist in the business nomenclature. And many times we don't realize it, we don't think about it. But the thing that we call policy coverage really is an ontology. And it's an ontology, it's a grouping of the scheduled coverage. The scheduled coverage has an identity based on its relationship to the policy insured subject. And the blanket coverage has a relationship the policy itself. That makes it a general coverage across all of the insured subjects. And so what that does is essentially what the policy coverage does, allows us to group them together for two reasons. From a business standpoint, it allows us to define the extent of the exposure in aggregate under the policy by grouping them together. It also allows us to express a business rules where there is common structure, substructure under each of these that is exactly the same. And so that what we call the policy coverage obligation, which is the deductible and the limits, those are common to both scheduled coverage as well as blanket coverage. And I have more examples of this. This is a very simple example. Actually, if time permits, I'll show you something from another industry where we've done this with facility and inventory and things like that. Essentially then what we've done here is these are ontology classes instead of a taxonomy class. And then to even refine this even further, we have created exclusive OR relationships that tell us that these relationship pathways are actually the ontology grouping relationships. And you'll notice is generalized by grouping as a policy coverage. So I even put those in. And so this all gives the LLM cues that these things, that essentially the blanket coverages and scheduled coverages are grouped up, and then all of the the sub functions of the sub ontology of the policy coverage is actually applicable to the two taxonomies. But essentially we do that, and then you'll notice in all the other relationships we don't have an exclusive OR relationship. So all of that's information that we take up into the knowledge graph. We've written the extracts as well, so that's one of the things you get with these models is we've written the extracts to move the entity relationship knowledge model and move that knowledge up into the knowledge graph. We do that with Top Grade today. That's part of Top. That's one of that's Top Quadrant's graph modeling tool and usable with knowledge graphs. So that's a partnership we have as well. Let's see. Well, we're kind of at the 45-minute mark. There's a lot more I wish I could show you. There's more examples of ontology and taxonomy use. Hopefully you get a little bit of a glimpse of what we're talking about, of the knowledge that is really required for the LLM to understand your business architecture. Give you a little bit of a glimpse of what these models are really about.
So in summary then, Accenture's created some industry standard reference models for a variety of industries. We've been looking at the insurance one today. One of the questions was, which other industries are you producing these reference models for?
We have reference models for the healthcare insurance space, the payer space. We are in the process of building out a robust consumer products. What I think the term is now, well, it's consumer products and goods and services. It includes manufacturing and some of the logistics as well. I have a little snippet here. Let's see. I think we're still showing the screen. This is a example ontology out of that, a conceptualization where we're showing the taxonomy grouping into the facility for the different facility types, and then we demonstrate the business rules of distribution chain facilities and supply chain facilities as it deals with two different classes of inventory and inventory actions. This is very conceptual. We have this, there's a logical model behind this. And then one of the things we wanted to demonstrate is a manufacturing plant here is both a distribution chain facility as well as a supply chain facility, because it's carrying both types of inventory. So that was, so we're able to give very fine-grained detail to the business rules while still doing ontology groupings. And there's even more. We got, in the next article I'm about to drop, I go into kind of how the archetypes work in applying ontology discipline as well. And that's kind of represented in this model as well.
Cool. And I think there was a question there. Do you do anything for pet care?
Pet care.
It's quite.
So pet care is essentially a consumer products and services, right? So instead of providing goods, you're providing services, or you may actually also provide some goods as well. So yeah, I mean, we cover that as well.
So I guess that's the next question. So we've got a reference model which we can get started with, but every company is slightly different. Yep. So you guys will come in and provide the services to then refine that model specifically for that company.
Right, exactly. So one of the things that happens here, let me see where I'm at. One of the things that happens here, rats, it'll be easier to do this, won't it? Come on. All right. This is a great example of what happens in many businesses, right? Your business architecture is slightly different than the way a lot of folks do it, right? So in claims, and keep in mind, I'm showing you another ontology because many times many carriers actually do claims for facultative reinsurance and surety bonds in addition to policies. And so the policy, the claim itself is really an ontology because the business identity is established by relationships of different contracts for the claim. But one of the things that happens, is that we have to adapt this to the particular business architecture. These claims are single contract, multi-policy, multi-exposure claims, which means the loss unit comes together with the coverage under a policy claim exposure to form the policy claim exposure, right? There are clients out there that do single contract, single exposure claims. And so what happens is we just move this claim exposure with all of its relationships. The way we adapt that is we just move it up into the claim itself, into the policy claim, right? So there is some alignment that goes on in order to align with your business architecture as well as the nomenclature. And we do that because we have the narrative that we start out with, and it gives us a really good comparison point with the way an individual business actually works.
Good. So we've now got a comprehensive model of the information of the organization. You're calling it a business architecture model. It's held as a data model in ER Studio. So what do we do with it now?
I use the term business architecture to kind of essentially give the consumer or give the client a better understanding of the basis of what we're modeling. We're not modeling tables. That's not what we're doing. We're modeling knowledge about how their business actually works, how the business processes shape the business function. And that's why I use that term. Sorry for interrupting.
No, that's a good one. So from this model of this business architecture model, there's a number of things that we could do. So someone asked a question about solution modeling. So the use case that we're here to talk about today is how do we then use this model to drive an AI? There are obviously lots of other use cases we could use this for. We could take fragments of this to then kickstart the design for individual data assets. So ER Studio allows you to create physical models from subsets of this. You could drive something like a data mesh program in an organization. We can do lots of other discussions on that outside, but today we're talking about AI. So how do I get this into the hands of my AI?
How do we get this? We have written so essentially what you want is this business knowledge in the knowledge model, in the knowledge graph, right, of the LLM. We've written the conversions that take the data out of this model, out of the model format that we have here, and directly transport it in and load it to the knowledge graph. We've done that for top grade today. It can be done for other modeling tools. Just follow the same pattern that we would do it based on the same pattern. But yeah, I mean that's essentially what it, because remember and we're able to actually create a much richer node in the ontology tool, because we have additional classification telling the LLM that, hey, this is a taxonomy, or this is a grouping, right? This is a function, or this is a grouping of function. And so we're really enriching that knowledge that it works with as well. But that's all work we've already done. Yeah.
So you've written macros in EOS Studio that will export this model in the form that at the moment top grade will ingest, I guess. You can
a colleague of mine is really the expert on that side, Ray Coulter. I deal with the actual business, the modeling of function. That's my area of expertise. I would defer to Ray as to what he's used, how he's done that. He's really the expert in that area.
I think Ray's created some macros that will generate things like turtle files and OWL and RDF files, which can be ingested by any AI. But he's done some specific work for top grade. Great. Okay.
Yeah.
All right. There's a few questions on the screen. So someone's asking, is it possible to share the model? I think the answer is yes, absolutely. You can share the model. You just need to knock on Accenture's door, and there's a price tag associated.
There's a license agreement with it, and it's, like I said, it's a phenomenal value. Along with that license agreement goes services as well. So we supply this to our customers. Yeah.
I think after this session, we're going to send out your contact details and links to the recording of this, so you should be able to get everything from that. A few other questions. So how is party overly generalized while facility is not?
Yeah, great question. Facility, and keep in mind, so there's archetypes behind this. And it depends on your use of party. So if you're linking back your business actors and you fully detailed out your business actors, but you want those linked back to a common identity of an individual or organization, then there's nothing wrong with party. I do that myself. I will link back the internal actors who are employees back to an employee definition sometimes as well, and link that and then relate that to my HR model, right? We also have an HR model, by the way. So we deal with the operational side. We deal with the commerce architecture as well as the operational architecture. But where was I? So there's nothing wrong with that. The problem is when you start generalizing all of the structure of those actors and their function into a model that essentially the generalization is that you lose the taxonomy, right? Now, the facility definition I've done, and what you're not seeing is you're not seeing the rest of the things that are specific to the manufacturing that are part of the manufacturing plant's taxonomy, part of the distribution center's taxonomy, part of the farm's taxonomy, those structures. What we're doing here at the facility level with the facility is defined by, and with the ontology, right? There is, whenever you do an ontology, by the way, you should first formally define what the archetype is that you're forming that ontology around. That's part of the discipline of doing this. With facilities, whenever we define a facility for the commerce architecture, slightly different for operations, but they're part actor. These particular facilities are performing a specific action at a location with infrastructure, with resources, right? And so what we're elevating to the facility level is everything that is common and only the things that are common. You'll notice from the facility here, we're also drawing in the relationship of the manufacturer, and this is done conceptually. There's actually more plumbing, relational plumbing in the logical model that does this, but we're drawing in the relationship of the manufacturing plant to the inventory, and that's done through the lot, or the essentially through the manufacturing lot that comes out of the manufacturing plant. But essentially, what has to be represented from a taxonomy standpoint in order to express the business rules we do, and what is general to all of the taxonomies, we elevate to the facility level. And so by doing that, essentially we're able to push. We can push any one part of this down to any one of these, and we know that those are applicable. They're not done with metadata. That's the whole problem. Is that the taxonomy structure does not exist in the party model. It exists only in the database that the implementation was done in. Now, if you can figure out how to mine that metadata and put all of that together from a taxonomy standpoint and feed it into the LLM, you'll be good. But that's a huge job. We think that would be very difficult to do, which is why we've gone down this route with the taxonomy modeling.
Great. Thanks for that. Someone was asking about, and can RStudio supports of conceptual, logical, and physical models? Yeah, absolutely. We support all of that. What Don's showing you here is a company-wide enterprise logical data model. And there's abstracted views in here as well that give you a sort of conceptual layer. RStudio allows you to, so this is a sort of self-contained model in the RStudio world. You can create multiple models and you can link between them using universal mappings, which can be visualized through our team server products. So quite often you'd take, and we were talking about solution architecture, so you might take extracts of this using our compare merge tool to a separate project, which represents a data asset, and from that logical model that you've then refined, you can then generate a physical model, etc. The RStudio maintains the links across all of these, so you can trace up and down.
And by the way, we do have, so there's a conceptual model behind this as well. So we have a conceptualization of this for communication. We share that as well as part of licensing. So, yeah.
Nice. Okay.
And conceptualization is actually not only conceptualization isn't just part of the development of the model. We come back and we update those conceptual models after the fact as well to align them with the logical model.
Nice. Someone was asking, I'm just sort of pushing on because we're running out of time. Are there any useful links to sort of explanations of ontologies and taxonomies, definitions? I think maybe we put a little pack together of a few links to some of your videos and resources that people can look at afterwards.
Sure. Yeah.
Final thing then, so you've been showing RStudio. I believe that there are other data modeling tools out in the market. Why are you using RStudio?
We use RStudio because of the efficiency. I've used all the other modeling tools. They have all of them, whether it's Power Designer or Irwin. These are the three tools I've used. They have features I like, in them, and I wish, I wish some of those features were also in RStudio, and we kind of ask for those, and we think that eventually some of those features will make it in. But I use RStudio, and I'm as adept with Irwin or Power Designer as I am with RStudio, but RStudio is extremely efficient. So I can create a submodel for a very customized piece of communication in a matter of minutes just by selecting things out of my main model and pulling it down and just saying, create submodel, and then coming back and getting things and putting it in. That's a more difficult task in Irwin, right? The printing, the banner printing, and I don't know what you guys did, but the banner printing is seamless. So I go to Adobe DC Pro, right? And I can just go into the postscript sizes and set my postscript size for the scale of the model, and then print it, and it comes out, right? It comes out in the banner print, works perfectly. I have to go into Irwin, I have to do page sizing. I've never been able to figure out how to do that in Irwin quite right. It's just way more work. It's a very inefficient process. At least it used to be. I don't know if they've changed it recently, but so it's really a matter of the utility. It's a matter of just the ease of use of the tool. If you know the narrative, it doesn't take you long to produce these models. So I want that modeling process as efficient as possible, and it supports everything we want to do, right? So I happen to believe that ER Studio has a more modern interface than the others, and that's one of the reasons why it's more efficient. The macros are phenomenal, right? They allow us to take information out, put information in, and customize those macros further. We've recently added the ability to include the entity, the attachment bindings for the entities in our metadata outputs for both the entity as well as the attributes. That allows us to sort and group entities and do estimations, solution estimating, and things like that. And so that it's just a very efficient way of performing modeling. And it's the tool that we actually recommend to our clients when they need a modeling tool and they don't have one.
That's great. Thank you very much. I think we've covered most of the questions. We've definitely run out of time. Don, thank you so much for that. That was really good, really interesting. Everybody else, if you want more information, there's a barcode on the screen. We'll be following up with you afterwards, giving you some links to good stuff, and hope to see you all again soon. Thanks very much for tuning in.